This video is on time domain representation of linear time invariant systems, popularly called as LTI systems. What are the methods of time domain representation of LTI systems and what is the need of such a representation? Such methods help in describing the relation between the input and output signals of LTI systems. They are useful for analyzing and predicting the behavior of the LTI systems, and more importantly, they are useful for implementing discrete time systems on a computer. What is convolution? It characterizes a LTI system in terms of impulse response. Impulse response is the output of a LTI system due to unit impulse input signal applied at time t equal to 0 or n equal to 0. This impulse response characterizes the behavior of any LTI system. It is the basic property of LTI systems. Impulse response is got from the knowledge of the system configuration and its dynamics. For unknown systems, it could be measured by applying suitable impulse to the system input and the impulse response could be obtained. Impulse response of discrete time system is got by setting the input equal to the impulse delta n. Let us consider what are the time domain representations of LTI systems. The first method would be convolution integral for the continuous time case or the convolution sum for the discrete time case. The next one would be the linear constant differential equation or the difference equation. The third one would be the block diagram representation, and the last one would be state variable description, which is not a part of the discussion for this subject. Convolution. By linearity and time invariance, the output signal is basically the weighted superposition of time-shifted impulse responses. The weighted superposition results in convolution sum for discrete time systems. On the other hand, such a weighted superposition results in a convolution integral for continuous time systems. Let us try to understand how the expression for convolution is obtained. Recall that for an impulse input, we had considered an expression given by integral minus infinity to plus infinity x of t delta t minus t naught dt is going to be equal to x into t naught. If the impulse input is replaced by the impulse response h and t naught is replaced by a dummy variable tau, the expression becomes integral minus infinity to plus infinity x of tau h of t minus tau dt becomes d tau, and hence because it is the impulse response, this becomes the response of the system, hence x of t naught becomes replaced by y of t. This is exactly the expression for convolution integral. Symbolically, the convolution is represented as y of t is going to be equal to x of t into h of t. Let us go on to see how the convolution of two sequences h of n and x of n could be represented. Hence, this could be given as y of n is going to be equal to summation k equal to minus infinity to plus infinity x of k into h of n minus k. Let us go on for a problem on discrete convolution. Y of n is going to be equal to k equal to minus infinity to plus infinity x of k h of n minus k. Let us determine the convolution of x of n is going to be equal to 5, 1, minus 2, 4, 0, 0, etc. and h of n is going to be equal to 1, 2, 3, 0, 0 and so on. Thus, we are going to consider an input of 5, 1, 2, 3 and 1, 2, 3 for h of n and consider the problem. Such a problem will be discussed in the next video. One more problem is expressed. Find the discrete convolution of x of n is going to be equal to u of n minus u of n minus 4, which is going to be equal to 1, 1, 1, 1. When we solve this, we get it as 1, 1, 1, 1. Similarly, delta n is minus delta n minus 2 would result in 1, 0, minus 1. So let us try to determine what would be the convolution. This is also given in the next video. Let us go on to the quiz. First question is, identify the methods of time domain representation of LTI systems. The answer is convolution, impulse response, time shifting and time invariance. When we consider the third one, that is time shifting, it is a property of a signal. This is a property of a system and this is the response of impulse input. So the only method for time domain representation is convolution. Similarly, the second question states the convolution of continuous time system is expressed as sum, difference, integral or differentiation. We are now aware that for continuous time systems, the convolution is represented by the integral. So the answer is 1a and 2c. Is going to be an integral. The solution is 1a and 2c. Next we go on to the references, which are as usual Oppenheim and Simon Haken.